Okay, so I think we have sufficient numbers, so we can start, I think. Okay, so up to the last class, anyone having any confusion, any doubt that you want to clarify?
No, sir.
Okay, others, how about the others? Vishwajit, seems like not in the call. Okay, I hope others are actively listening because it is online class, it is having some advantages as well as disadvantages also. Okay, so it's up to you people also. You should be self-regulating and you have to like be you should be responsible enough. Okay, otherwise just joining in the class and after that if you just don't be attentive and all, then the whole motive of doing the class it will be like it will not be fulfilled, right? So I know that it becomes sometimes difficult for you people also, but still you should manage with whatever is the new norm. Okay, so if you have any question, any doubt after the last class, you can clarify. Okay, so what we have discussed in the last class. So in the last class, we have solved certain problems. Okay, regarding designing of the bell and checking about what is the like effect of sleep in the Velis ratio, or similarly using that we have selected the proper diameter pulley and all. Okay, so dimension of pulley when we know about the suppose velocity of a drive and all. Okay, so those kind of problems we have solved. And similarly, bell designing problem we have also solved for a particular application. Like we know about the suppose the what is the power transmitted, some pulley diameter, etc. Okay, what is at what speed it is rotating, coefficient of friction, etc., and like permissible stress. Okay, so those kind of thing, knowing those kind of situation, we have also selected the bell, other bell parameter like the width of the bell, which will be required for that particular application. So in that problem, we have also considered the centrifugal tension. We have considered centrifugal tension into account, and considering that basically using the known knowledge, known relationship about tension, maximum tension, like how it can be obtained if we know about the sigma, that is the permissible stress, the cross-sectional area, etc. Okay, so sigma bt, T equal to sigma bt, using those kind of application formula. Similarly, using the centrifugal tension formula, etc., because we have to consider the centrifugal tension as per that particular question, and using other known relationship, like ratio of the tension in tight as well as slack side. Okay, for flat bell drive. So those kind of all those relationships we have utilized, and we have obtained that particular unknown, that was the uh, regarding that particular width of the bell. Okay, so that kind of bell designing problem also we have solved, and later on also one small problem we have solved, like for selection of the length of the bell for a particular application. So there we have done we have solved that particular length of the belt required for open belting as well as cross belting. There we have seen that for the same application, okay, so the length of the cross belt is somewhat more than that of your open belting. So in case of open belting, considering the similar situation about the central distance, about the dimensions of the pulleys and all, considering all those things, we have obtained the length of the open belting as 33.13 meter, and whereas for cross belting, for the same case, we have obtained approximately 33.45 meter as the required length of the belt. Okay, there we have seen that. That means generally length of the belt in case of cross belting is somewhat more because of that arrangement itself. Okay, so now today we are going to solve another problem somewhat which relates to the designing of this particular belt itself. Okay, so after this one, any question, any doubt that you want to clarify, you can ask, or if no, then you let me know and we'll move ahead. Seems like no. Okay. So now we'll go through this particular problem statement. So what does it say? It says that two pulleys, one of 450 millimeter diameter and another of 200 millimeter diameter, are on parallel shafts 1.95 meter apart and are connected by cross belt. Okay. So from next, what we are asking, you have to find the length of the belt record first. Okay, and the angle of contact between the length of the belt required, and angle of contact between the belt and each pulley. Okay. Now, in the same question, they are also asking what power can be transmitted by the belt when the larger pulley is rotating at 200 rpm and the maximum permissible tension on the belt is 10 to the power 3 Newton, and the coefficient of friction between the belt and the pulley metal is given as 0.25. Okay, so from here, so you should be able to first find out what is the length of the belt required, what should be the angle of contact, as well as the max, you have to also find out the power transmitted. Okay, within this particular condition. Okay, so now once you have this particular question, okay, so what are the main thing that you have from this particular question? Okay, what are the data that you have obtained? So two pulleys, one of 450 millimeter and the other is of 200 millimeter. So D1 and D2 they are given. So D1 is 450 millimeter, convert to meter, 0.45, it becomes 0.45 meter, and D2 is 200 millimeter. Okay, we have converted to meter. So from the diameter value, easily we can obtain the radius value for both the cases, like half by half of the diameter is nothing but the radius, so R1 and R2 value will get. Okay, next, in the question, from the question itself, you have got they are on the two parallel shafts which are 1.95 meter apart. Okay, so this is what that means, this is the value of the center distance x. Okay, so center distance x equal to 1.95 meter, and they are connected by cross belt. Okay, so you should in the given data itself you make a note, that means it's a cross belting. Okay, so that is also important because we know that the length of belt, to find the length of belt for like both the cross belting as well as open belting, the relationship that you have to consider is different, and the way the belt is mounted in case of cross belting definitely is different than that of your open belting. Okay, and also that cross belting or open belting also influences the angle of contact. So angle of contact also later on we have to find out. So cross belting you highlight, that is it's a cross belting. Next, what is being given, the, also they are asking what power can be transmitted if the larger pulley rotates at 200 rpm. So N1 is given as 200 rpm. Okay, and the maximum permissible tension in the belt is given as 10 to the power 3 Newton. Okay, so now here you can do one thing. So as nothing is being said about centrifugal tension, whether you have to consider it or you don't have to consider it, then as nothing is being mentioned, what you do, you from yourself you just mention that we have not selected, we have not considered the centrifugal tension. Okay, so centrifugal tension TC we have not considered, so that will make your problem somewhat easier. You don't have to go for all those mass of per unit length, the velocity of it. Okay, so as to find out TC. So once you make this particular statement, that means we have not considered centrifugal tension, then the maximum permissible tension on that particular belt itself is nothing but the tension in the tight side, that is T1. Okay, because we know that the maximum tension actually it is nothing but the maximum tension T equal to, we can write T1, that is the tension in the touch side, plus the centrifugal tension. Now we have not considered the centrifugal tension. Okay, so it is, that means kind of zero, we have not considered it. Okay, you'll just mention we have not considered it because nothing is being said in this question about considering or not considering centrifugal tension. So for we will be by ourselves will be saying that we have not selected, because another thing also is there, it is just rotating at suppose 200 rpm or so. Okay, somewhat still it is in the lower speed range, so we can neglect it, no problem. But if suppose it is like 1000 rpm or so, then you should not neglect that particular thing. Okay, so now in that case, so T1 itself is, it becomes 1 into 10 to the power 3 Newton, that means 1 kilonewton, 10 to the power 3 Newton, and mu is given as 0.25. Okay, up to this pass in the given data, any question, anyone, any confusion? I hope no. Okay, so after that, in the we'll go through the different whatever is they are asking to find out. Okay, so first thing is you have to find out the length of the belt. So it's a cross belt. So we know for cross belting how we can get that length of the belt. LC can be given by pi whole into R1 plus R2 plus 2x plus R1 plus R2 whole square. This is become this. Here it is plus. Okay, in case of open belting it is negative. Okay, R1 minus R2. Okay, so here it is R1 plus R2 divided by x. So we have just put that particular value of suppose R1, R2 which are already there. From diameter value we already have the radius value, the central distance value is already given, other values are directly we can put, and we have obtained the length of the belt for the cross belting as 4.975 meter. So this completes the very first step. Now from here we can also have the linear velocity of the belt, just like in the previous case how we can obtain. So v equal to pi d1 n1 by 60. So we know that v equal to pi dn by 60. This way we can get, right? So corresponding d1 and n1 we have considered d. Okay, so we know that it's for pi dn by 60. So if we consider you have the d1 and n1 value, okay, so for this particular value pulley we are just considering it. Okay, and after putting the value it's already given as 200 rpm. T is already given as already 0.45 meter by putting it. So linear velocity of the drive we have obtained as 4.71 meter per second. Okay, now as per the question what we need to find out, so length of the belt is done. Okay, so also we have to find out the angle of contact between the belt and its pulley. So this is what kind of belting? It's a cross belting. Okay, so how we can get the angle of contact in case of cross belting? So if you recall this particular figure of cross belting, the cross belting is something like this, right? I think I have rotated this. Let me, up to this class, any question, anyone? Let me know, understood or not.
Yes, I understood.
Okay, okay. So now if you recall about the cross belting, so this is nothing but the cross belt, right? So this kind of configuration is there. Yes, so we have this pulley, bigger pulley, we have this smaller pulley, and this is the belt. Okay, the belt leaves this portion, this particular pulley in this particular portion, comes in contact here in the smaller pulley, it is being wrapped around here, and after that it all leaves here and comes in contact here. Okay, so now if you recall your that length of the belt we have considered there, this kind of diagram already we have drawn. So this angle is 2 alpha angle, right? So this total angle. Okay, and this angle as well as this angle is alpha. Similarly here also if you consider this plus angle, okay, it's alpha, this is alpha. Similarly this way also this is alpha, right? So those things are after. So now for this particular pulley radius is r1. Okay, and for this particular pulley radius is r2. Okay, now if we consider suppose this center line, okay, this one, if you consider this particular center line, okay, then this angle becomes alpha. Okay, similarly here also it becomes alpha, and if we just obtain up to this center line, okay, and this is nothing but the radius for it. Okay, so this also it will be r1 only, and if you draw a line, if you extend here, okay, and from here if you draw a line which is parallel to this particular belt, okay, then it becomes a kind of triangle, right? And this angle will be alpha, this angle from the geometry will be alpha, and this mass is r1, and this extended portion will be same as that of this radius, right? Because it is parallel to this line. Okay, so this portion is same as that of your this portion.
which is nothing but the radius of the smaller wheel, that is R2. Right? Understood up to this first? This is R2. Okay. So now that means from here to here, it is radius of this particular bigger pulley R1, and from here to here, that is this line only we are talking about. Okay, so this mass is R2. So if you consider this triangle, extended triangle, so this line becomes, this side becomes R1 plus R2. Okay, similarly this one becomes your the central distance. Okay, this angle is alpha. Okay, and it's actually kind of right angle triangle only. So the trigonometric relationship all of you can use. Okay, understood up to this first? Let me know.
Yes, sir.
Okay, so now that means from this particular diagram itself we can write, we know for cross belting. So as we have already seen, so sine alpha can be written as R1 plus R2 by X. That means this side R1 plus R2 by, this is the central distance X. Okay, that will give you this particular angle sine alpha value. Okay, and from the R1 and R2 we already know, X already we know. So from here sine alpha we have obtained this 0.166, and from there alpha is 9.594 degree. Okay, so now alpha is known. Now we need to find out actually which one. We don't require alpha, but we need angle of contact. Okay, now if you recall how we can get the angle of contact for cross belting, so it is 180 degree plus 2 alpha. So it is 180 degree plus the 2 alpha gives you the angle of contact for cross belting. For open belting it was 180 degree minus 2 alpha. Cross belting it is 180 degree plus 2 alpha. So just now we have found out alpha. So it will be very easy. You can very easily find out the angle of contact for cross belting as 180 degree plus 2 alpha. So which will give you in terms of radian if you consider. So it will become 3.476 radian. So here itself you can convert it to radian, because later on while using the ratio of the tension, that particular expression we need to use it in radian, otherwise it is 199.18 degree. Okay, up to this much I hope all of you have understood. So after that what we have done, we have just used, we have considered as a flat bell, as nothing is being said about whether it's a free belt, flat bell. So for flat bell our task becomes easy. So also write down, so for flat bell what we know, the ratio of the tension T1 by T2 is given as e to the power mu theta, right? So this is a very known expression for flat bell, ratio of the tension for driving for the tight and the slack side. So mu is already given as 0.25, e to the power mu theta just now we have obtained as 3.476 radian. So we have just put the value and we have obtained T1 by T2 as 2.3845. Okay, that is the ratio of T1 by T2. So from here what we can have, so we already have the tension in the tight side, we already have, that is T1 we already have. Okay, and the ratio of T1 and T2 we have the value. So T2 we can very easily find out from there by using T1 value. So that is what we are doing. So that means the tension in the slack side T2 can be obtained as T1 by this particular value 2.38 something. Okay, and T1 is given as 1000. Okay, and from there T2 we have obtained as 419 Newton. Okay, up to this much it's done. After this much, is it okay? Yes or no?
Yes, sir.
Okay. So after that, what we have, what is required? So what we have done, length of the well we have found out, angle of contact we have found out. Okay, and maximum tension etc. Those things are given. So coefficient of friction between belt and the pulley is given. So and what they are asking, also they are asking the power transmitted. Okay, so for power transmitted we already have this particular relationship. We know that power transmitted can be obtained by P equal to this ratio of we can say the effective tension, that is T1 minus T2, T1 minus T2 into the velocity of the drive, okay, into V. This is just like P equal to FV. So this becomes the equivalent force, okay, tension, this which is the effective tension, that is nothing but a kind of force. So T1 and T2 we have. V already we have found out in between, that is by doing pi d1 and 1 by 60. So we are ready with T1, we are ready with T2, and also we have the velocity value. So that means by using this particular formula, we can use to find out the power transfer. So power transfer is equal to P equal to T1 minus T2 into V. So T1 value is given as 1000. T2 just now we have obtained as 419.37 Newton into velocity of the drive. V already we had. So from here 4.71 meter per second. So this value we are using, and we have obtained power transfer to be 2734.76 in watt. So what's the unit for power? It's a SI unit is watt. Okay, and this completes this particular problem. So in these problems are very easy once you know this standard relationship, and you are your in your mind the configurations are there. So these problems very easily can be solved out. Okay, you can, all of you can solve very easily. Understood or not? Let me know.
Understood, sir.
Thank you. Others, what about the others? It is sir.
Yes, sir. Understood.
Yes, sir, understood.
Okay, Kandip, Digyas.
Yes, sir. Understood,
Okay.
sir.
Okay, thank you, thank you. So, you do one thing then, these kind of other problems from belt, okay, you try to solve by yourself, okay, and with this basically this part from this particular module we have covered. That is the main part was with respect to belt only, okay. We still have some other small part in this particular module. Already in the very beginning we have discussed about the frictions, okay. So that problem is there, and so now some application of other like use of like this particular friction drive also we have considered. That is bladle drive, basically we have discussed bladle drive, rope drive, okay. And what we will discuss also some application like the in case of bearing, okay, anti-friction bearing or bearing lubricator, the different types, or similarly friction clutches and brake, okay, how basically they work, okay, in the in a kind of not in that much depth, okay. So those things in designing etc you will be studying in machine design, but how they work, or what is the how friction plays the role in all those friction clutches and brakes and all, okay, mechanical brakes. So that kind of things we are going to discuss in the from the next class, okay. And that will complete that this particular module, and we'll be left with the last module, okay. So with this basically today's discussion will stop here, and we'll be taking the attendance now. In the meantime, if you have any question, anything to ask, you can ask. So for your class test 2 is also coming, right?
Yes, sir.
Start studying for it, okay. If you start from now, it will be easy. And if you have any question, definitely you can ask, okay. So okay, now I'll be taking the attendance, I'll be calling the names. You can, those who are active, you respond to me. Catherine,
Yes, sir.
Subham, Subham, Norangsi, Norangsi, Vishal, Norangsi, you are traveling somewhere. Seems like Norangsi is traveling. Vishal, Vishal, Samim,
Sir, I'm also present, sir.
Present, sir.
who is also present.
It's me, Vishwajit, sir.
Yeah, I have not still called your name. Okay, I'm going by as per the whatever is being shown in Google Classroom. That serially I'm coming. Okay, Google Meet. Catherine is done. Subham, Subham is not here, no? Norangsi, Vishal, Vishal.
Sir, I'm present.
Yeah, Norangsi, it's done. Vishal is not here because you are not active. Your name is showing, but that means it's you're actually you just opened the meet and you're not here actually. Samim is done. Hitesh sir.
Yes, sir.
Vishwajit is done. Okay. Jigyas.
Present, sir.
Ashish.
Sir,
Present, sir.
Vishal present.
Vishal, what happened? You're sleeping or what? Vishal, you're sleeping or you're asleep or what?
No, no, sir, I'm outside. I can't unmute.
Jaideep,
Yes, sir.
Mario, you're also on travel. So this way you'll be like what to say. Try to be attentive. If you just keep on traveling during class, just join the meeting. It's of no use. Mario, I think his network problem is there. Okay, Sempang. Okay, no. Okay, Mario done. Sempang,
Present, sir.
Sina,
Yes, sir.
Tapas,
Present, sir.
Jorian, Jorian, Jorian. Okay, seems like he is also not active. Okay, others, anyone left out? Shubham is here. Andreas, not here. Khandip, you are there. What happened to Khandip? I think he got out. Okay, so I'm giving to Khandip. He was there. Jorian, Jorian's name I can see, but you are not active, so I am not giving the attendance today to Jorian. Sensing Dao, also not here. 1, 2, 3, 4. Okay. Okay, so thank you everyone for joining. So Jorian, I have not given to Jorian, okay? Let him know. Because so many times I have been calling him. Actually he's not here.
Thank you, sir.
Okay. Okay, thank you. Thank you everyone.
Thank you, sir.
Hmm.
Thank you, sir.
Okay.
Thank you, sir.